Good morning, dear students. So let's start the exercise 5.2. So in exercise 5.2, the first question it is sine. We have to differentiate that sine x square plus 5. Okay. So how to differentiate this sine x square plus 5? How to differentiate this function? So first d dx of sine x square plus 5, it will be what? D dx of sine theta. D dx of sine theta, it will be cos theta. So cos theta means cos x square plus 5. Then we have to differentiate whatever there in the bracket, that is the polynomial function. So it is d dx of polynomial function, that is x to the power 5. Now it is cos x square plus 5. It is d dx of x square plus d dx of 5. Clear? So now cos x square plus 5 d dx of x squared is 2 x to the power 2 minus 1, then plus d dx of constant, that is 0. So it is, you can write it as 2x cos x to the power 2 plus 5. So this is the derivative or differentiation of this function sine x square plus 5. So now let's do the second question. The second question is that it is given cos in the bracket sin x, cos in the bracket sin x. So same process, d dx of cos theta, it is minus, it is cos theta, it will be minus sin theta, means sin of sin x. It will be already, first we have to write it, then this will be the second step. So this will be what? Equal to d dx of cos sin x, it will be equal to cos theta, it will be minus sin theta, it will be sin x. Then here again we have to differentiate the whatever the function in the bracket. So it will be d dx of sin x. So now it will be sin of sin x, then d dx of sin x, it will be cos x, then d dx of x. So d dx of x is 1. So now it is minus cos x sin x. This is the answer for the second question. So let's proceed for the third question. So what it will be, third question. Third question it is that sin ax plus b, sin ax plus b. Same process, d dx of sine ax plus b. So first we have to take x plus b as theta. So differentiation of sine theta will be, it will be cos theta. So cos theta means ax plus b. Okay. Then d dx of ax plus b. Now it will be cos ax plus b. Then d dx of this, it is d dx of ax plus d dx of b. So now it is cos ax plus b. d dx of x, it is a will be this side, come this side because a is constant, and it is dx upon dx plus d dx of b, it is a constant, b is a constant, so it will be 0. So now what we will get? The answer it is that uh, equal to cos ax plus b, and here a dx of dx, it is a 1. So a multiply 1, it is a. So now it is a cos ax plus b. So this is the answer of the third question. So now let's proceed for the fourth question. So the fourth question, it is sec tan under root x. Fourth question, sec tan under root x. So differentiate it, d dx of sec tan under root x. So here are the three functions. So you have to do one by one. So first, d dx of sec theta. Sec theta, this will be theta. So what will be sec theta? The differentiation of sec theta, it will be sec x. Sec x means sec tan under root x, then tan under root x, because we know that the differentiation of sec theta will be differentiation of sec x will be sec x multiplied tan x. So it will be sec tan inverse tan under root x and tan under root x, because this is theta. Or we may take it as x. If sec x will take, so tan inverse x will be x and tan inverse x will be x. So sec x multiply tan x. Now d dx of whatever in the bracket, that is tan under root x. So it will be sec tan under root x tan under root x then d dx of tan under root x. So means here it will be tan theta. So we have to take this as theta. So what will be the differentiation of tan theta? It will be sec square theta. So here theta is under root x. So sec square x. Then whatever in the bracket, that is differentiation of under root x. So now it will be sec tan under root x, then tan under root x, then sec square under root x. Then what will be the differentiation of under root x? So under root x is what? The differentiation of under root x, it will be 1 upon 2 x to the power 1 upon 2 minus 1. Why? Because under root x is equal to x to the power 1 upon 2. Okay, so let's take the half this side. So it will be half, then write the sec square under root x, and it is also x to the power minus half. So x to the power minus half means under root 1 upon 2 under root x. Now sec square under root x, then sec tan under root x, then tan under root x. So this is the answer of the differentiation of sec tan in under root x. So note it down. Let's proceed for the next question. The next question it is sin ax plus b upon cos cx plus d. So before doing these questions, so we must have to know some formula related to this. So what are the formula? I'm just writing here. That is, you just note down this formula related to this to solve these two questions. That is question number 5 and 6. To solve the question number 5 and 6, where we apply this formula. So formula, so what is the formula? That is d dx of uv, means multiplication of two functions. It will be equal to u dash v plus u v dash. So where u dash v dash are what? Derivative of u and v. Then d dx of u upon v, d dx of u upon v, it will be u dash v minus u v dash upon v square. So here are the two formulas. We must have to know that to solve the question number 5 and 6, and here v is at the denominator, so where v should not be equal to 0. So these two formula we must have to know to solve the question number 5 and 6. So let's do solve the question number 5. So in question number 5, the question it is that sin x plus b and cos cx plus d. Sin ax plus b upon cos cx plus d. So let's take, let u is equal to sin ax plus b and v equal to cos cx plus d. Clear? So now we have to find out the derivative of u, that is u dash. U dash will be equal to d dx of sine ax plus b. So it is equal to, first of all, same thing, it will be theta, so sine theta, the derivative of sine theta will be cos theta, and here theta is x plus b. Then derivative of d dx of ax plus b, and we know that it will be cos ax plus b, then d dx of ax plus d dx of b. Okay, so now d dx of ax, it will be a dx, and dx of b will be 0. So here finally we will get a, and here it will be a cos ax plus b. This will be the value of u dash. So now v dash, so it will be d dx of cos cx plus d. So it will be equal to, so d dx of cos theta, it will be minus sine cx plus d, then d dx of cx plus d. Now here it will be minus sine cx plus d, d dx of cx plus d dx of d. So now it will be minus of c. d dx of cx will be c, because c will be this side, so c dx upon dx, it will be 1, so c, and ddx of d will be 0, because d is a constant, so you will get c here, so it will be minus c sine cx plus d. So here we find u dash upon u dash and v dash, and also we know u and v. Let's put in the formula, that is d dx of u upon v. So the formula is uh, d dx u upon v is equal to u dash v minus u v dash upon v square. Okay, so u is what? U we took sine ax plus b. It will be u, and here we have to take u dash. So u dash will be what? U dash will be a cos ax plus b. Then v, it is cos cx plus d. Okay. Then minus u. U means it will be sine ax plus b, then v dash. So v dash will be minus c sine cx plus d. So here we may write in multiplication, that is minus c sin cx plus d upon v square. So what is the v? V is cos. V will be cos cx cos cx plus d, the square. Okay. So now you have to simplify this. So let's simplify. So it will be a cos. I have to write this like this. So cos ax plus b cos cx plus d. Then this minus this upon this. So it will be what? This upon this. Then this upon this. So you have to split up this. So it will be cos cx plus d ka square means cos square cx plus d. So 1 cos cx plus d will be cancel out. Now here it will be minus and here it will be minus, and it will be plus sin uh, okay, ax plus b, then c sin cx plus d upon cos square cx plus d. Okay, now here what it will be? A cos x plus b, a cos ax plus b, and here one cos will be cancelled out and another one cos left below. So it will be 1 upon cos cx plus d. We can write it as sec cx plus d. We can write it as sec cx plus d. Then plus, I am writing here, see here, sin ax plus b. We can write it like this. First we have to take this c to the front. So take c sin ax plus b. Then here left sin cx plus d. Okay, write it like this. Sin cx plus d upon here cos square cx plus d. I can write it like this. Cos cx plus d and multiply 1 upon cos cx plus d. We are doing just to take all the functions above, means in a single row. Then only we are doing this, otherwise up to this our answer is correct. Okay. So now what do we have to do? It will be a cos ax plus b, then sec cx plus d, then plus c sin ax plus b, then sin 6 plus d upon cos 6 plus d. Sin theta upon cos theta, it will be tan theta, so it will be tan, we may write there just below, otherwise you will be confused. So here we may write like this, tan cx plus d, then 1 upon cos 6 plus d is sec cx plus d, and this is the answer. Otherwise we may also take a common C, Cx plus D, and here also sec Cx plus D. We may also common this, then, and that will be the final answer, otherwise it will be the answer. Okay, I think all of you can understood about this. So let's proceed for the next question, that is question number 6. So what is the question number 6? It is question number 6 is that question number 6, cos x cube dot sine square x to the power 5, sine square x to the power 5. Okay, so here also two function u dot v, u multiply v. So let's take, let u is equal to cos x cube and v equal to sine square x to the power 5. Clear? Now, what is the formula? d dx of uv, it will be derivative of uv plus u derivative of v. Okay, so this is our formula and we have to apply this. So to apply this, we must have to find the u dash and v dash, means derivative of u and derivative of v. So derivative of u, it is d dx of cos x cube. So x cube is theta, so it will be d dx of cos x, cos theta, it will be minus sine theta, here it will be x cube, so minus sine x cube and d dx of x cube. So it will be 3x to the power 2. So now we can write here 3x to the power 2 sine x cube. Now at this level you may expertise to derivative such type of polynomial functions. That is, the power will be multiplied alongside and 1 will be minus from the power. So 3 multiply x square. So like this, v dash means d dx of sine square x to the power 5. So sine square x to the power 5 means what? It is sine x to the power 5 whole square, means square. Now first of all we have to solve this square, so it will be 2 alike side and then it will be sine x to the power 5. 2 minus 1, then d dx of sine x to the power 5. Okay, so now it will be 2 sine x to the power 5 to the power 1, means 2 sine x to the power 5. Now d dx of sine x to the power 5, it is sine theta, so it will be it will be cos theta. It will be cos theta, means cos x to the power 5, then d dx of x to the power 5, it will be equal to 2 sine x to the power 5 cos x to the power 5. ddx of x to the power 5 means 5 multiply x to the power 5 minus 1, and that will be equal to 2 sine x to the power 5 cos x to the power 5, then multiply, here 5 will be multiplied here 2, so it will be 10, then x to the power 5 minus 1 is 4, so we may write here 10 x to the power 4. Okay, so this is u dash v dash. Let's put it in the formula. So that is ddx ddx of uv, it is actually u dash v. U dash it is minus 3x square sin x cube. So put it minus 3x square sin x cube, then multiply v. So v is what? Sin square x to the power 5. Sin square x to the power 5. Okay. Now next is plus u v dash. So u means this is u, it is cos x to the power 3, cos x to the power 3, their v dash is 10 x to the power 4 sin x to the power 5 cos x to the power 5. Okay, so you may simplify this. So we may take this portion to the front because this is plus and this is minus. So it will be 10 x to the power 4, and it is cos x to the power 3, then cos x to the power 5, then sin x to the power 5, then minus 3 x to the power 2, then sin x to the power 3, then sin square x to the power 5. This is the answer. So note it down please. Let's proceed for the next question. That is question number 7. In question number 7, where it is 2 under root cot x square. It is question number 7. So it is given 2 under root cot 2 under root cot x to the power 2. So same process it is d of dx of 2 under root cot x to the power 2, it is equal to, so we just have to take 2 to this side because it is constant. So now it is ddx of cot x to the power 2. It means what? It will be cot x to the power 2 to the power half, because under root we can write in the power half. So now it will be 2, the power, it will be here alongside, then we may write cot x square, then half minus 1, then d dx of cot x to the power 2. So 2 will be cancelled. Now here it will be cot x to the power 2 to the power minus half. So d dx of cot x square. So it will be the differentiation of cot x. It will be minus cosec square x. X means here x square. Then ddx of x square. ddx of x square, the polynomial function. So now here we can write this. It will be equal to, so here it is minus, so take minus to the front. Minus, here it will be minus 1 upon 2, and it will be what? Minus 1 upon 2, so it will be 1 upon cot x square under root, because minus 1 upon 2 means it will go to the denominator. Now cosec square x square cosec square x square, then it will be x square. So x square, the differentiation, it will be multiply 2x. So now it will be minus 2x cosec square x square upon under root cot x square, and this is the answer. So note down please. So let's proceed for cos under root x. Question number 8, cos under root x. So I think you can do it by yourself. You just do it by yourself. DIY means do it by yourself. Question number 8. Now let's proceed for the last two questions which we have to prove. So what we have to prove? That prove that the function f given by this fx equal to modulus x minus 1, x belongs to R, is not differentiable at x equal to 1. So first of all, we know that the definition of the differentiation. So what is the definition of differentiation? That if f is a function, f is a function, then its differentiation will be f dash, it will be equal to, then its differentiation at a point, at a point C will be f dash, and it will be fx minus fc upon x minus c, provided F dash will be equal to limit x tends to c fx minus fc upon x minus c, provided the limit should exist. Limit should exist. So it means what? Limit should exist. What it is, I already told you. Limit should exist means its lower limit and upper limit, or its left hand limit and right hand limit should be equal to each other. Then only this function will be differentiable at that point C.